Oopsie daisy, forgot to do a kind of horizontally arranged area between curves. Better late than never. So here we have two curves that are parabolas oriented horizontally. Okay, first a word about sketching these things. Okay, you'd start with, y, whoops, y is equal to x squared. It would look something like this. Okay, so x is equal to y squared would look like this. And now for this guy, we're just going to shift it to the left by 9. So, something like this. So it's a parabola opening to the right. Now the other guy has a negative in front of the y squared. So it'll be something like that. And my goal now is to find these intersection points. Because what I'm going to be doing is forming a integral, but now, the rectangles are oriented like this. Anyways, intersection points. Intersections. Well, I set these two curves equal to each other. And bring everything to the left. Minus 3y minus 20 is equal to 0. And this happens to factor like so. Is that right? Yeah, it's right. 0. So y is equal to negative 5 over 2, or y is equal to 4. Those are my intersections. So what these numbers tell me is that the integral I'm going to form is going to be from negative 5 over 2 to 4. And it's going to be something, and then I'll have a dy over here. I'm going to have a dy because I'm thinking of this horizontally. And if you think of a rectangle here, that little bit of length is a vertically oriented bit of length. So I have a delta y. So when you take your limit of your Riemann sum, you get dy. Okay, so before we were doing, or above we were doing, upper function minus lower function. But now, because this is the positive x-axis over here, we're going to be doing the rightmost function subtract the leftmost function. So here's a more accurate picture down here. And the calculation below. So as you can see, I do rightmost function instead of the upper function. And I do leftmost function instead of the lower function. But otherwise, it's quite similar to what we've done before. And as noted above, you can see my intersections end up as the endpoints of my integral, because we are doing an integral from y equals negative 2.5 up to y is equal to 4. Okay, I made a mistake. This is a 4, right? Should be a 4, not a 3. Likewise over here. It should be a 4. This number down here is actually correct. I just did a typo when copying out my solution. One more thing I want to say here is Well, why don't we use our old method? Why don't we do upper and minus lower? Well, I want to draw your attention to a couple problems. First of all, if I look at this diagram here, upper minus lower, it's just not going to work, right? Because you have a change happening here. Okay, if let's say I'm here, you can see upper and lower are in fact the same curve. That is a problem. That is one problem. The second problem is that if I go over here, upper minus lower is different, right? The blue curve is the upper and red curve is the lower. Okay, so that's a complication, a further complication. Now that's why we're doing things horizontally here. Okay, if I do things horizontally, the leftmost curve and the rightmost curve are always the same thing. Okay, they don't change anywhere in my region. But if I try to do upper and lower, there are all kinds of problems. Okay, this will come up again in 6.2, but I'll just touch on it here.